And we have around 10 minutes before lunch for the discussion. So actually, maybe you can stay. Maybe all the speakers could come up here. Sorry. And we can see if people have more questions or discussion for any of the speakers.
Okay, I guess I have a microphone, so I'll start. It's Martina Hrušinska again, and this is for Giuliano, so the first talk. I disagree with one of the statements you made, so maybe you can respond to this. It's about, so you said something like, uncertainties in the metallicity-dependent cosmic star formation history are not enough to explain the over-predicting of the rate for. So, as you know, the two parts of the modeling, they degenerate in black hole population properties, in particular in the local merger rate density. Simple example, if you have a model that leads to very weak dependence on black hole formation efficiency on metallicity, then uncertainty in the metallicity-dependent cosmic star formation history will not do much. And there you can make the statement easily, if that model overpredicts the rate by a factor of more than a few. But if you have a strong dependence on metallicity and formation efficiency, and say short delay times, then even the systematics in metallicity estimates are enough to affect the rate estimate by a factor of 10. So this is a statement you can make for a particular model if you know the uncertainty in metallicity-dependent cosmic star formation history. That's why it's important to understand this uncertainty. So can we agree that this statement is a bit more like, it's important to make it a bit more specific?
Yeah, okay, so do you mean that, well, I agree that this really depends on both directions. So but for the merger efficiency, there is the tendency always to show this kind of, let's say, trend with metallicity. And unless, well, if you go to dynamical formation channels, this is washed out, of course.
Sure, I mean, we have a lot of room to play with parameters in the stellar evolution.
Yeah, right. But
problem,
we really have to fine-tune a bit to flatten it. I agree it's possible. It's based on many uncertainties that we have. But we have to change something fundamental. This is my point. Yeah.
Okay, so the point I'm trying to make is that the impact of uncertainties in metallicity-dependent cosmic star formation history actually gets worse if you have strong dependence on metallicity.
Right.
And some of the, you showed this plot from the review, some of the points that are a factor of a few tenths of the local rate, you can probably make consistent with the LIGO band still by just playing with uncertainties in the metallicity-dependent cosmic star formation history. If that's more like a factor of 100, perhaps this is where we can make this statement already.
Yeah. Okay. Yep. Agree in general. So you mean, anyway, these uncertainties should reduce the importance of the low metallicity, star formation intensity at low metallicity, right? This is the point.
I'm not sure I understood this, but yeah, I guess we can follow up.
I want to make a following up statement, actually, defending at least Giuliano's title, which says, are we overproducing, are models overproducing the rate? And I think you can kind of be a little bit worried if you just look at the formation efficiency of binary black holes, black hole neutron stars, etc., plots themselves. Because we usually always say, oh, it's really difficult to form binary black holes. It's 1 in 10 to the minus 6 solar masses formed. But I think that's an unfair comparison, because if you look at that plot that Jan also showed, you should not be comparing to all the star formation in history. You should be comparing to all the stars that could realistically produce binary black holes. And if you do that, then you get another upper limit, and then you see that a lot of these binary channels, or a lot of the population synthesis models, at low metallicity predict that 1 in every 8 stars or binaries that could form a merging binary black hole can form a merging binary black hole. Now, I don't know if that is, truth or not, but 1 in every 8 doesn't seem very rare to me. That actually sounds like we're pretty over-optimistic about how many stars, binaries can form, merging binary black holes, taking into account that they also have to produce mergers and unbound binaries. So I think, yes, I agree with everything Martina said, but I also agree with Giuliano, and I think our models are probably overestimating their rates.
I'll have something for the first speaker. After the first two, so I understand that we are focusing on, okay, the rate at 0, whatever, 0.1, 0.2 is too high, right? However, we are now, and even more so, 5, in a situation where we'll also know the slope. So will the slope help you understanding what's wrong, like which of these factors that could all contribute on the magnitude to be off, to be more likely? So project 205, where I think, Giuliano, you add the uncertainty from the LVK, and right now I think both of the possible slope would, be within the error bars. 5 make the uncertainty a factor of, whatever, smaller. Does that help you rule out some of the possible reasons?
Well, yes, I think so. Now I don't have a single reply for this, but of course it's an additional set of information that one can retrieve from models and see also not only the magnitude but also how the slope will change. I think can help for sure.
Yeah, I think I agree with that. I think in general, in all of the models, like in both in the like binary evolution side and in the like cosmic star formation history side, there are a lot of uncertainties that as you kind of vary them, it may account for variations in like the slope of the rate. So I think that kind of looking at multiple different observables, and especially as detectors are going to be able to detect binaries to higher redshifts. I feel like when we're going to be going to higher redshifts, that is the point at which it's going to start becoming easier to differentiate between different models and hopefully starting to rule out some models.
Yeah, maybe just a quick thing too. Like one thing that Ariana's work can do is take any delay time distribution that you guys predict and tell you exactly what cosmic metallicity evolution you need in order to make that happen, and then directly check if that's consistent with any simulations. Okay, sorry, Adam.
Yeah, all these talks were very informative. I learned a lot. I have a comment and then a question. The comment was for the last speaker. The implication seems to be at least that more massive stars will likely give you black holes, and less massive stars will likely give you neutron stars. And while that probably is true, it's possibly the case that much less massive stars can give you black holes. So that is part of the inputs to some of these population synthesis codes that have an implication for what channels form black holes, et cetera. So I think one should be cautious. This question is for probably Ariana, but also perhaps Jacob, but Ariana. You have a delay time distribution, it's a power law, and people have commented about the problems with that perhaps. If you have a power law that's truncated, is it not possible that that's indicating that you could form a large number of eccentric binaries where the eccentricity is completely lost over time because of the gravitational loss and evolution of the eccentricity, but that would certainly truncate things so that you don't have very long delay times. Maybe stepping back, is it possible that what you're seeing is that there aren't long delay times for one reason or another, given the formation scenarios that are more likely?
Thanks for your question. So in the work that I'm doing, I set the maximum as just like the age of the universe, because the things that we see today.
So that's realistic.
But that is something that could be modified if a particular formation channel
may be worth
calls
doing.
for that. Yeah. Thank you.
Very short in the context of triples. The neutral star black hole mergers I was talking about, they have effectively no delay time because you already derived a merger after a few Kozai cycles. That's the case for the NSBH mergers. Once you have binary black holes, it's getting a bit more complicated because you have a mixture of so-called adiabatic and non-adiabatic mergers, which just tell you they just describe of how far your tertiary companion is. For binary black holes, in order to survive a binary black hole, triple your tertiary companion can't be much wider because of less constraints from the neutron star formation here. And there it's getting a bit more complicated, and I think poorly understood what's sort of the mixture between long delay times and short delay times. But I think generally the delay times that you get in Kozai-driven mergers is much shorter than for isolated binaries.
Yeah, hi. This was great, a great set of talks, a really great start to the whole conference. I'm just wondering, and this is to any of you, what are we learning about galaxy host properties? Like, can you make any statements at all about what the hosts of these systems might look like?
Actually, that is kind of the direction of my future work. So I guess that is things I'm hoping to explore in the future and hopefully have some more answers about that. Yeah.
Okay, I think it's lunchtime, so yes. Great. Let's thank all the speakers again. And yeah, I see you back when lunch ends at some time.